Lesson 8.2 is determining the number of x-intercepts. So we talked about this with quadratics. Remember when we graphed a quadratic function and we said we want the solutions or the roots or the zeros? Those are also known as finding the x-intercepts. Sometimes we had two, sometimes we got imaginary roots, which means it doesn't even look like it has any x-intercepts. So number 1 and number 2 should look very familiar what we've already done. We're just wanting, though, the real values of x. We want to know where on the graph are we going to actually see the function go through the x-axis, not the ones that are the imaginary. They don't really exist. And so when I solve an equation like this for x, because I couldn't factor this as a difference of squares because 10 is not a square, I would add the 10 over, making it positive. Then to cancel out the squared, I would square root both sides. Your job is to simplify this radical if you can, but 10 does not have any perfect square factor in it. So this is just going to get positive or negative square root of 10. Now a square root, that's okay. That's not imaginary. That's just some kind of decimal that never stops. So you do get the two answers, positive square root of 10, negative square root of 10. And I'll just show you that square root of 10 is about 3.16 and negative square root of 10 is about negative 3.16. So those are real values. But number 2, if I solve, because this starts out with a plus 25, when I go to move it to the other side, now we get a negative 25. And when I square root a negative, that's the problem, because no number squared is going to result in a negative. Whether it's a negative or a positive x value, squaring it always makes it positive. So this is plus or minus 5i. And so that does not have any real solution. So you would just leave like the empty set on Delta Math. So we'll put like no solutions or 0 with a slash through it. The next section says how many x-intercepts would the function shown below have? So again, it wants just the real ones, not the imaginary. And the good thing is these problems are already in factored form. Factored form means you're going to see parentheses. See how this is already split up into its factors? That's good. So what I'm trying to do is figure out where does y equal 0, setting it equal to 0. And I want to draw lines down through everything with x that I see, every factor. So any monomial, one term pulled out saying this is x, set it equal to 0, so x would be 0. That's a real answer. This one, if I had it set equal to 0, I would add the 3 over and then square root both sides. So x would get positive, negative square root of 3. Those are real. The next one, I would have x minus 3 is my only factor. It's occurring twice, but that doesn't matter. I'm going to just add 3 over, and I get x equals 3. So again, let me clarify that if I were to expand that out, I'm just getting an answer of 3 twice. If you have the same answer occurring twice, we don't count it twice. We want to see each unique answer. Okay, and then the last one, so again, I'm going to have this factor twice, so I'd get the same answer twice, but I just need to solve one of them. I'm going to subtract the 4 over, making it negative, divided by 5. So x would be negative 4 fifths. So I get an answer of 0, so there's 1, 2, 3, because I count the positive and the negative, 4, 5. 5 x-intercepts. They don't even care what the answers are, they just want to know how many. All right, and then the last one, remember you're setting this y value equal to 0, and you're setting each factor, there's a lot of them, equal to 0 and solving. Remember that when we have a number pulled out in front, that doesn't even have an x to solve for, so that says that 5 needs to equal 0, which is never possible. So that one is not part of an answer. This one, I would subtract the 9 over, making it negative, and then I would square root both sides. X equals, sorry, positive, negative, that would be 3i. That does not count since that's imaginary. Okay, next one would be adding 6, so at least it gets a positive, and then square rooting. So I get plus or minus square root of 6. There's 2 answers. This one would just simply be 5. This one I would subtract the 1 over and divide by 6. So I get -1/6. And then this one would be 5. So again, I don't count these twice. So my unique answers are 2, 3, 4 different x-intercepts. And that's it.